The sciences use a metric system of units because it makes calculations very, very convenient. All you're doing is moving decimal points. These most common prefixes are the ones that you're responsible for knowing in this chemistry course. We are asked to convert between milliliters and liters. So we recall the identity that needs to be used. 1,000 milliliters is equivalent to a liter. That allows us to write two different conversion factors. Now we choose the appropriate conversion factor based on the units we need to cancel. We need to cancel milliliters, so we know we need to use the conversion factor with milliliters in the denominator. We write the conversion factor and see that our units cancel. A good sanity check is to make sure the top and the bottom are equivalent values. 1 liter is equivalent to 1,000 milliliters. Now we know we need to divide by 1,000 in order to get our answer. As a final step, we make sure we check our Sig Figs. We see that this number has 3 Sig Figs. This is an exact value because it's based on a definition. And that means it's not going to impact Sig Figs. So we know we need to express our answer with 3 Sig Figs. In this next problem, we're asked to go between millimeters and centimeters. I suggest that you go through meters. So you go millimeters to meters, meters to centimeters. So here are the two associated identities. 1,000 millimeters equal a meter, 100 centimeters equals a meter. So each of these identities can be used to write two different conversion factors. And note, as always, we have equivalent quantities in the top and the bottom. We choose our first conversion factor on the basis we need to convert between millimeters to meters. So we want to cancel out units of millimeters. So we know that 1,000 millimeters is equivalent to a meter. That means our millimeters have been canceled out. Now we want to go from meters to centimeters. So we need to cancel out units of meters. So the meters goes in the denominator and centimeters in the numerator. And again, we can check to make sure we have equivalent quantities in the top and the bottom. 100 centimeters is equivalent to a meter. Now that we know we have this set up correctly, we do the associated math. The 275 is divided by 1,000 multiplied by 100. Again, numbers in the denominator indicate division. Numbers in the numerator indicate multiplication. Our result is 27.5 centimeters. So let's look at Sig Figs. 3 Sig Figs in our initial number. This is exact, so it does not impact Sig Figs. This is exact, so it does not impact Sig Figs. So our final answer should have 3 Sig Figs. It already does. We're set. Okay, looking at this problem, we're going from kilograms to grams. We recall our identity, and therefore we can write our two different conversion factors. We choose the conversion factor that's going to cancel out kilograms because kilograms is there in the denominator. So we have our setup. We see that kilograms cancel and grams survives as a unit in our answer. And our final answer should have 3 Sig Figs, which it already does. We're done. Right, we have our initial setup. We want to go from centimeters to meters. We recall that 100 centimeters is equivalent to a meter. So we can write our two different conversion factors. We want to use a conversion factor that has centimeters in the denominator so that we can cancel out units of centimeters. 100 centimeters is equivalent to a meter. So our units of centimeters cancel out. We get our desired unit, meters, and we do the appropriate math. 475 divided by 100 is 4.75.